All right, in this video, 12.6, we are looking at some counting methods, permutations, and combinations. So this video will have some definitions, and then the next video will have some examples of your homework problems. So first, you can find the possible orders of objects by making an organized list. Okay, that's one way. Another way is to make a tree diagram. Both methods help you see if you have thought of all the possibilities. So using a tree diagram, suppose you have 3 shirts, a blue, red, and green, 2 pair of pants, blue and brown, and 2 pairs of shoes, black and browns, that coordinate well. How many different possible outfits can you choose from? So first I'm going to show you a method called the tree diagram. So let's list off all the shirts. We have a blue, we have a red, and we have green. Then for the pants, we have blue and brown. So for each shirt, we're going to have a blue brown pair of pants and a brown pair of pants. For the blue shirt, for the red shirt, and then for the green shirt. For each of the pants, we're going to have a pair of shoes. So for the blue pair of pants and the blue shirt, we'll have black and brown shoes to choose from. For the blue shirt and brown pants, we'll have another black and brown. So we're listing them all off for each one. And then to find out how many different possible outfits, then we count the last tree part, if you will, the last branch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 different possible outfits that we can choose from. And that's looking at a tree diagram. Oops. Now, when one event does not affect the result of the second event, the events are independent. When the events are independent, we can find the number of outcomes also using the multiplication counting principle. So we just use the tree diagram. This is another method called the multiplication counting principles. If there are m ways to make a first selection, for example, picking 3 different colors of shirts, and n ways to make a second selection, like 2 different pairs of pants, 2 different colors of pair of pants, then there are m times n ways to make the 2 selections. So here, using our tree diagram problem, we're now going to look at it using a multiplication counting principle. So if we have 3 shirts, 2 pairs of pants, and 2 pairs of shoes that coordinate well, how many different possible outfits can we choose from? So we're going to take the number of shirts times the number of pants times the number of shoes, and that will give us our total different outcomes that we can choose from. So there's 12. So there's 2 different ways of doing that. Preferably, you're going to want to use the multiplication counting principle instead of a tree diagram. All right, another count, or one kind of counting problem is to find the number of possible arrangements of the objects in a set. A permutation is an arrangement of objects in a specific order. So order matters. This is important for permutation. Order matters. How many different batting orders can you have with 9 baseball players? So the order matters. So first, we have 9 baseball players. So when we first choose, we have 9 batters to choose from. So we've chosen 1. Now we have 8 batters to choose from. So now we've chosen 2, so we now have 7 batters to choose from, and so on. Okay? Now, that's a lot of numbers to plug into a calculator. So there actually is a shortcut on your calculator, and it is called the PRB, the probability button. So when you're looking at your calculator, it's over on the second column, I believe. So what you're going to do is first type the number of baseball players, 9. Then press PRB, PRB. And when you press PRB, it's going to show up and it's going to have 3 selections. It's going to say NPR, NCR, and it's going to have an exclamation point. When you first press PRB, the dotted line is under NPR. You need to move that dotted line so that it's under the exclamation point. And then type enter twice. The first time you type enter, you're going to see this on your calculator. The second time you type enter, you're going to see the answer. 362,880 different ways that we can arrange 9 baseball players. Okay. Now, we can also use, and that, by the way, that exclamation point is called factorial. So you can use factorials to write a formula for the number of permutations of n objects arranged r at a time. So this is the formula for n objects arranged r at a time. We do n factorial over n minus r in parentheses factorial. Now that is the formula, which, you know, is good to know, especially if you don't have a calculator. So I'm going to show you how you can use that formula without a calculator, and then how you can use the calculator also to do the same formula. So in how many ways can you select a right, center, and left fielder? So that's 3 different positions from 8 players on a baseball team. So to answer this question, you need to find the number of permutations of 8 objects, 8 players, arranged 3 at a time. So using the formula for n for permutations, n factorial over n minus r factorial, n is the number of players, so 8 factorial over 8 minus r, which is 8 minus 3 factorial. Now, 8 factorial literally means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Let's squeeze that in. 8 minus 3 is 5 factorial. So that's 5 times 4 times 3 times 2 times 1. So we can cancel out the 5, 4, 3, 2, and 1. And now I'm just multiplying 8 times 7 times 6. Now, that's a lot to do, but since I have a calculator, I'm going to make it a lot easier on myself and use the calculator. So, we're taking 8 players and we're arranging them 3 at a time. So in the calculator, we're first going to type the 8, how many players that we want to choose from. Then type the PRB button. Now remember earlier I told you whenever you type the PRB button, the first thing you see is the NPR. And it's already underlined the NPR. So just hit enter and then type the 3. The 3 tells me that I'm taking 3 different positions. So I'm taking 8 players arranged 3 at a time, a right, a center, and a left fielder. And then hit enter and you'll see that it's 336, which just so happens to be what 8 times 7 times 6 is. Okay, so from now on, I'm not going to use the formula. I'm just going to use the calculator using the PRB button. I just wanted to show you how that worked. All right, so that's permutation. Now, also we have combination. A combination is a selection of objects without regard to order. For example, you're selecting 2 side dishes from a list of 5. You have green beans, and you have mashed potatoes, macaroni and cheese, you have rolls, and, I don't know, a salad. And you want to pick 2 of those. So it doesn't really matter. Most people, it doesn't matter which side dish you choose first. So that's where order doesn't matter. All right, so let's look at examples. Suppose you're making a sandwich with 3 of these ingredients: turkey, cheese, tomato, mayo, mustard, and lettuce. So how many ingredients are that? 1, 2, 3, 4, 5, 6 ingredients. And we're going to choose 3 of those. Now, the order doesn't matter. Most people don't really care what the order of their ingredients on their sandwich is. So we're going to use the C button this time. So a combination is a selection in which order does not matter. We're going to use the NCR. Now, this is the formula. Again, I'm just showing it to you. If you want to write it down and memorize it, that's up to you. But as long as you have your calculator, you're not going to really need that formula. All right, so we're going to type 6 because we have 6 different ingredients. Then click the PR button. The dotted line, remember, is under NPR. So use your arrow key to place the dotted line under NCR. Hit enter and then type 3. That's how many different ingredients we're choosing. And then hit enter. So you're going to see the answer is 20. Okay. All right, so there's 3 different things we looked at. We looked at multiplication counting principle, where order matters but repetition is allowed. Where order matters but repetition is not allowed, we're going to use permutations. And when order does not matter, we're going to use combinations. So, order, if it matters, we have two different choices. Repetition is allowed, that's multiplication counting principle. Repetition not allowed, that's permutation. Just to be clear on this, permutation, you're going to see where it's in objects arranged R at a time. Okay? So really, you'll be able to tell the difference between a permutation and a multiplication counting principle. And then if order does not matter, we'll use combinations. All right, so that's the end of video 1. Let's go to video 2 and look at some of those examples.